Hey, so in this video, I am going to talk about rational expressions. We spent quite some time on learning algebraic identities, and we also learned how to factorize polynomials. We went through actually the most important tricks and techniques for factoring polynomials. We already talked a little bit about one very main application of factoring polynomials, which was solving equations. But now I want to continue to another very important application of factoring polynomials, and that is manipulating rational expressions, simplifications, multiplication, division, and addition and subtraction finally. Yes. So the title of this video would be Rational Expressions. Yes. Okay, so all of you are familiar with the notion of rational numbers. Yes, a rational number is a number that you can write it as a fraction. For example, 3/4 is a rational number. It's a fraction. On the other hand, the numerator and the denominators are coming from the set of integers. Yes, so this is called a rational number. Here, I want to talk about rational expressions. Rational expressions are fractions again, but then the numerator and the denominator are polynomials. So if I have a fraction whose numerator and the denominator is a polynomial, I call this a rational expression. For example, I can consider x plus 2 over 3x minus 2. This is a rational expression. It's a fraction, its numerator is a polynomial in x, and its denominator is also a polynomial in x. Of course, I can have more than one variable, yes? I can assume that I have 3xy plus 2xz divided by 4x plus 2xz, for example. This is also a rational expression. It's a fraction. Its numerator is a polynomial in 3 variables x, y, and z, and its denominator is a polynomial in 2 variables x and z. Okay, so the topic of this lesson and a few more lessons, coming lessons, is the notion of rational expressions, and then how I can simplify rational expressions, how can I multiply and divide rational expressions, which would be the subject of this video actually. And then later we will learn how to add two or more fractions, rational expressions, or subtract them. Okay, so that is the topic of the lesson. The first thing that we want to do is to learn how to simplify a rational expression exactly as we knew how to simplify a fraction. Yes, so there are some important things in order that I want to mention them here for you. Yes, so here, for example, assume that I have 4/6. This is a fraction, it's a rational number, but you know that how can I simplify that? Yes, in principle, you can do it immediately in your head and write 2/3, which is completely correct. But if you go back and look the process that your brain has done it is in this way. 4 has been, we can write it as 2 times 2, and 6 can be written as 2 times 3. Yes, and then you would say that, okay, this in principle can be written as 2/2 multiplied by 2/3, but by the rule of multiplication of fractions, and then any fraction whose numerator and denominator is equal are equal together is 1, and then you multiply it by 2/3, and any number multiplied by 1 is just the same number. Of course, you did it so quickly, probably you don't recognize these, but these steps become important if you want to simplify rational expressions. Okay, but so then you will see that the main point that we were able to simplify this expression was to write 4 as a product and 6 as a product. Then I find some common factor here. So if I don't want to write all these steps, I would say that these factors can be simplified from the numerator and the denominator, yes? And by factor, I mean a number which is multiplied by another number to construct that number, yes? So for example, when I write 6 is equal to 2 times 3, each one of them is called a factor. But if I write 6 equals to 2 plus 4, even though this equality is still true, but I cannot call 2 and 4 factors because of this, I can call them summands. They have been added to give me 6. So please differentiate. This is very important. Differentiate between the notion of a summand and the notion of a factor. Only factors, common factors, can be simplified from the numerator and the denominator. Okay, and that is exactly true for rational expressions. So let us review. If I want to simplify a fraction, what I do, I factorize the numerator, I factorize the denominator, and I look for all possible common factors and I eliminate them. And then what is left for me is the simplified version or irreducible form of my fraction. Yes, so that's crucial point. That is more or less the same for rational expressions. So let me clean this. So the only thing that is important to remember about a rational expression is the domain of the validity of that rational expression. What do I mean by that? So when I write 4 over 6, this is always and always a defined number. I'm dividing 4 by 6. But when I write a rational expression, for example, let us pick a simple one, x minus 1 divided by x. This is a rational expression, but this has some limitations because x is a variable and in principle can take on values. This expression can take any value except the value or values which makes the denominator equal to 0. Okay, so in this case, I can calculate this rational expression for every possible value of x except one single number, and that is 0. For example, this expression x divided by x squared minus 1 is not defined if x is equal to 1 or minus 1. If x is equal to 1, 1 to 2 is 1, 1 minus 1 is 0, the denominator becomes 0. The same argument for minus 1. Except 1 and minus 1, this is defined for every possible value of x. So that is called the domain of validity or the domain of the rational expression. So whenever from now on in these lessons I am talking about a rational expression, I always mean that you need to respect the domain of the validity or the domain of that. The domain of a rational expression is simply the all possible values, all real values for the variables such that the denominator of that rational expression is a non-zero number. Okay? Okay. So the first thing that we want to talk about simplifying expressions. Yes, simplifying rational expressions. Simplifying rational expressions. So what should I do? The recipe is as before. I factorize the numerator and the denominator. The numerator and the denominators are in general polynomials, and we spent quite time to learn how to factorize polynomials. Use all your knowledge about factorization of polynomials, factorize the numerator and the denominator, and then try to see what are the common factors between the numerator and the denominator. And then you can eliminate them, and what is left is the simplified version of the same rational expression. Of course, we all the time put equality between those simplified versions, but we mean that they are equal if and only if I am respecting the domain of the validity or the domain of the rational expression. Okay, so let me start as usual with very simple examples, and then we increase the level of difficulty little by little. So example, so simplify. So I will start with a simple example. Number one, I want to simplify 15xy over 25y's. Yes. So the first step is that, is it a rational expression? Yes, the numerator is a polynomial in two variables x and y. The denominator is also a polynomial only in one variable y. This expression is defined everywhere except where this denominator is 0. It means that I am not allowed to choose y equal to 0. Okay, now if I want to simplify this, the first step would be to factorize the numerator and the denominator. Okay, but this is already in factorized form. Okay, so let me write all these steps. In principle, 15 can be factorized a little bit more, so it is 3 times 5, and then times x times y. You see, so I have 4 factors in the numerator, and then 25 can be written as 5 times 5. Of course, I can write 5 to the 2 and then multiply it by another y. Yes? So 1, 2, 3, 4 factors in the numerator, 1, 2, 3 factors in the denominator. There are 2 factors exactly in common. Yes? So 5 and 5 are in common. Y and y are in common. So I divide both the numerator and the denominator by 5. So when I eliminate and remain nothing, it means nothing is 1 in this case because I am dividing both the numerator and the denominator. And the same is true, I just divide by y, and I am allowed to divide by y because I'm assuming that y is not 0, because if y is 0 in the first place, I cannot define it. And then this becomes again 1 and then 1. So then what is left? 3 times 1 times x times 1. So it becomes 3x. And in the denominator, I have 1 times 5 times 1, which becomes 5. Yes? So I would say that this expression is equal to this simpler expression, but you need to be careful. You need to respect the domain of validity. Even if you don't see any track of y in this expression, you cannot say that this expression is equal to this expression for all possible values of y, because you also need to, your starting point is here. So it means that this equation, this one is equal to this one for all possible values of x, that's okay, but for values of y which are not 0. Okay, so that is the simplified or a reduced version, reduced version of my fraction. Okay, now let us go to the next problem. So number 2, I have minus 9 divided by 18 x squared y. And I don't think I really need to write all the details, but you need to respect all the details. You don't need to write them, but you need to think about them. So here, of course, you see that I have one number here. I have a product of number 18 with 2 factors of x and 1 factor of y. All of them are in factorized form, so I can simplify. Yes, between minus 9 and 18, I can divide by minus 9. So it becomes, so I can divide by 9, it becomes minus 1. And I can divide this by 9, it becomes 2. Yes, I'm able to simplify because these are factors, but nothing is left. So the answer would be minus 1 divided by 2x squared y. And I usually prefer to put this negative sign behind and write this. Of course, that is not mandatory. So, and I'm using this. There is no difference if you write a over b equals to, so minus a over b, or a over minus b, or minus a over b. Okay, let us go to the next example. So example number 3. So I can do it a little bit more quicker. So minus 28 a squared b squared divided by minus 63 a squared b cubed. Yes? Okay. So I want to continue and simplify this for the same reasons. It is written in the it's already written in the product form. It's factorized. So first of all, this negative sign and that negative sign, when I divide, this cancel, and this 28 can be simplified by 7. If I divide this by 7, 4 is left. If I divide this by 7, 9 is left. And this a squared, 2 factors of a and 2 factors of a are totally gone. 2 factors of b simplifies 2 factors of b here. 1 factor of b is left. So when I say nothing is left here, it means that I am dividing, so 1 is left. So when I divide this by b squared, only b is left. Here is also 1 left. And then minus signs are cancelled, so 4 times 1 times 1 is 4. And then I have 9 times 1 times b is 9b. Again, this is not valid for all possible values of a. You need to respect that a shouldn't be 0. Okay, number 4. So number 4 is this expression, x squared plus 4x divided by x squared minus 16. Okay, so make sure that you understand none of these x's can be simplified by any one of these x's, and 4 cannot be simplified by 16. That's crucial. The reason is that x here or there, they are not factors of the numerator or the denominator. Okay, so for example, x is just a partial factor of only this term. X is a partial factor of only this term, but in this form, x is not a factor of the whole numerator. So first of all, you need to factorize everything, and I think that this is super simple for you if you have followed my video on factoring polynomials. So here I can pull x out, and then I am left with x plus 4, and then I can factorize this using the conjugate pattern, so it becomes x minus 4 and x plus 4. Yes. Now, if I ask you what are the factors of the numerator, you would answer, in the numerator, let me call n for numerator, I have one factor x, another factor x plus 4, and for the denominator, I have 2 factors. One of them is x minus 4 as a whole, and the other one is x plus 4. And then you see that in this list, and in this list, I have something exactly identical, and that is x plus 4. Please do not get used to this way of writing, but you need to think in that way. So then what happens is that this x plus 4 and this x plus 4 can be simplified. Simplified means that 1 is left instead of them. Okay? So I can simplify because they are factors. And then x times 1 is just simply, sorry, let me keep the color. So this gives me x times 1 is x, and then the denominator, I have this expression multiplied by 1, which is the same expression. And there is no extra need for this pair of brackets, so let me remove them. And then I hope that you understand that you're not allowed to simplify these two x's, even though x is the factor for the whole expression, it is itself, but it is not a factor for the denominator, it's a summand. And then I cannot simplify. So that would be the end of this problem. So you see, nothing new is here. So it means that if you have harder problems of this kind, if I want to make a harder problem of this kind, I need to make the numerator and the denominator harder from the point of view of factorization. Yes? That's it. So let me give you some more examples. Number 5. Let me simplify this expression as much as possible. So 6x to the 3y minus 6xy, and then divide this by x to the 3 plus 5x squared plus 4x. So I want to simplify this. So what can I do? You see, I need to factorize. it is not in factorized form. And then you see that 6x and y are in common in the numerator, so I can factor it out. So it becomes 6xy, and what is left is x squared minus 1. This one. And then you see that I can factor an x out here. X, and I will have x squared plus 5x plus 4. Of course, at this stage, you can simplify these two because these are factors, but don't be in a hurry. I would prefer to factorize them as much as possible, then start simplification. If the problem is a big one, I will separately factorize the numerator. When it's finished, I put it in a box to finalize it, and then I go to factorize the denominator. Then I will transfer them into one problem and then simplify. That's up to you, of course. This is something completely subjective. And then hopefully you know what to do. So 6xy, this is a conjugate pattern, so it becomes x minus 1, x plus 1. And then the denominator, I hope that you recall, how should I factorize a quadratic polynomial? It is the simplest version. So I put two x's in two pairs of brackets, and I ask myself that I need two numbers whose sum is equal to positive 5 and the product is 1. So the product is 4. So it's clear that one of them is 1, the other one is 4. If I add them, it becomes positive 5. If I multiply them, it becomes 4. Now everything is in order. I can safely simplify. Okay, this x, so the factors are 3. X plus 1 as a whole, x plus 4 as a whole. Here I have 2 and 3, 6. And then I have x, y, x minus 1, and x plus 1. Yes? So this factor and that factor can be simplified. So you don't need to write 1 all the time, but this is the way that you need to think. X plus 1 is simplified with that x plus 1 and nothing more. This is very important to realize, nothing more. So what is left in the numerator is just 6 and y and this expression, x minus 1. And then in the denominator, 1 times this, because this is only x plus 4, I don't really need to have the pair of brackets around it. And usually I myself prefer that if nothing simplified, I remove the pair of brackets by multiplying back, but this is I could call it optional. So then it becomes 6yx minus 6y, and then divided by x plus 4. So this one is the simplified version of this expression, and you see that this is quite simpler than the previous one. Okay? So let me go to the other example. So let me write here on the board so that I don't need to erase so much. So we go to number 6. Yes? So let me write here. So number 6, I am supposed to simplify this expression, 6a squared minus 7a plus 2 divided by 10a minus 15a squared. Okay, so I want to simplify this. Again, I need to factorize the expressions. So how can I simplify this? I factorize the numerator. So you need to remember how to factorize a quadratic polynomial, but this time this coefficient is not 1. If you have followed the videos, there are different ways to do this. One way that I sometimes prefer is I multiply these two numbers in my head, so it becomes 12, and then this is minus 7. And I ask myself that I need two numbers whose sum is equal to 12, whose sum is equal to minus 7, and the product is 12. Okay? And then I immediately find them. So let me write like this, because let me write this. I would write numerator is equal to, I would write 6a squared. Immediately I can guess these two numbers. What are those numbers? The product is supposed to be 12. The sum should be minus 7. Of course, the numbers are minus 3 and minus 4. Then you learned from previous videos that you need to break the middle term into, for example, minus 3a and minus 4a. Minus 3a minus 4a is the 7 minus 7a. And then I have plus 2. And then you need to group them, yes? So this one I take together, I factor a 3a out, then I will have 2a's, 2a, yes, and then I will have minus 1 here. And then I can factor a negative 2 out from here. It is 2a minus 1 again. And then there is a common factor emerging so that I can factor 2a minus 1 out. And that is 3a minus 2. Yes? Okay. And now if I go to the denominator, this is simple, yes, because it is clear that I can factor 5a out, yes. Between these two, I can factor 5a out, and then I have 2 minus 3a. Yes, and now the fraction, so let me write the question mark, becomes equal. Instead of numerator, I write 3a times 2a minus 1. I need to, this is my factorized version. I write 2a minus 1 times 3a minus 2. And then I divide this by this expression which is in the denominator. Okay? But now look, something interesting happens and you need to know about this. If I ask you what are the factors here, you would say 2a minus 1, 3a minus 2, 5a, 2 minus 3a. These two factors are not exactly the same. So don't be in a hurry to cancel them out. Because this is 3a minus 2, 2 is negative, 3a is positive. Here 2 is positive, 3a is negative. So they are not exactly the same. But you know the trick from the previous lessons, yes? So I can write 2 minus 3a. This has the wrong sign. So what I can do, I can factor a negative sign out. Then it becomes 3a minus 2, as we learned before. So it means that I can simply, in my head, instead of this, I can write minus 3a minus 2. Okay? Now this factor and that factor becomes identical. So it means that I can simplify this factor with that factor. So here 1 is left, but here because of this negative sign minus 1 is left. And then 2a minus 1 times 1 is just 2a minus 1, and the denominator would be minus 1 times 5a. I prefer to write 5a here. Instead of putting negative sign here, I prefer to put negative sign there. Yes. So that is also something that you need to know. Okay, let me do another example. So number 7, we are supposed to simplify this expression 6x to the 3 plus 3x to the 2 and then minus 3x. And then I have this divided by 2x squared plus x minus 1. Okay. So again, I need to simplify these two expressions. Factorize these two expressions. Okay, this is actually very simple. You see between these three terms, I can factor 3x out. So let us do that because I could see ahead of me. This is why I don't want to separate them. It's much simpler than that. So 3x, I factor 3x out. Then from here, I will have 2x squared. From here, I will have x left. And from the last term, minus 1 is left. And then I divide this by this expression. And I even don't need to factorize this. So even if this is factorizable, but I want you to understand the core, yes? The core is to have the same factors to cancel out. Even though this 2x squared plus x minus 1 can be factorized more, yes, the delta, do you remember the tricks? The delta that here I have is 1 plus 8, and this is 9, which is completely square. So it is factorizable in the realm of the integers. But it is not necessary at all because this is a factor of the numerator, and this is also a factor of the denominator, because this is the whole expression. So you really don't need here, when we were dealing with factorization, we have to continue until this is not any more factorizable. But here it's not the goal. The goal is to have the common factors and cancel them. Okay? And then when this emerges, that's enough. I can simply simplify these two, and then the answer becomes 3x. So that's also a very important point. It saves time for you, okay? Okay, let me go to the another one. So number 8, I want to simplify this expression, 12ax squared, and then I have plus 3ax divided by 8x squared plus 22x plus 5. Yes? Here, the numerator is super simple. The denominator is also very simple, but it needs to follow some steps. So let me do this separately. Let me concentrate here, okay? So I want to factorize the denominator first. Do you remember? This is one of those trinomials where that this coefficient is not equal to 1, is not a complete square. So what I need to think about is that I would say, I ask myself, I need two numbers whose product is the product of these two, which is 40, and the sum is this number sitting here, which is 22. It is super simple to guess, isn't it? And you know that if you cannot guess, I already told you how to do this in the previous videos. So here it is very simple to guess. One of those numbers is 20 and the other one is 2. If I multiply them, 40. If I add them, 22. And then I need to break this middle term into 20x and 2x. Okay? This always will work. So this give me this, and then I would write it as 20x plus 2x, and then plus 5. Okay, and then you need to group them in a way that after factoring of the common factor, a new common factor emerges. So then it would be obvious for me that I need to take these two together, and I need to take these two together. Yes. So what happens? This becomes 8. Between these two, I can factor 2x out, and then 4x is left from here, and 1 is left from here. And then if I factor 5 from these two, and then you see that the common factor that I was looking for emerges here, and that is 4x plus 1. And I factor 4x plus 1 out, so this becomes 4x plus 1, and then I will have 2x plus 5. Yes? Now, this you can do, and then you can go back and simplify your question mark. Here, I can factor 3ax out, and then I will have 4x from this and 1 from that. And then the denominator, I have already factorized that, so it is 4x plus 1 multiplied by 2x plus 5. And then the same reason, 4x plus 1 is a common factor. I can divide and cancel them. So 1 is left from here, 1 is left there. So it becomes 3ax. The denominator becomes 2x plus 5. And I don't need any pair of brackets there. Okay. So let me give you another example. Sometimes simplification is enough. Yes. So for example, number 9, let me simplify this expression. I mean, you don't need to concentrate on factorization only. Sometimes there might be some shortcuts. Yes, then I will have x plus y to the 2. Of course, in this case, you can still factorize. It is already in factorized form. It's a product, but it's not complete because each one of them is a conjugate pattern. But the denominator is also as a whole is a conjugate pattern. So you can focus on factoring things, and I recommend you to do it yourself. I want to follow another way because I want to tell you sometimes just simplification, expanding will also work, okay? But as a general rule, we need to factorize and then simplify. So for example, if I want to continue this, I multiply this, it becomes x squared y squared minus x squared minus y squared minus 1 times minus 1 positive 1. And then let me just expand the first one using the quadratic rule. The first one to the 2 is x squared y squared. 2 times the first one times the second one is 2xy, and the second one to the 2 is 1. And then I raise this one to power 2, but this negative sign is for all of it. Yeah, so you remember, x to the 2 multiplied by a negative sign minus x squared. 2 times the first one times the second one is positive 2xy multiplied by an extra negative sign, negative 2xy. And then finally, y to the power of 2 is positive, then I multiply, it becomes negative. You see, in the numerator, I cannot do anything extra, so let us keep it. So then it becomes x squared minus x squared minus y squared plus 1. But the denominator simplifies to this form. X squared, y squared is alone. Then this one, positive, and this one are gone. And then you let me write minus x squared and minus y squared. And then finally I have 1. You see, I am not following the common strategy of factorizing, because if I wanted to follow, I need to factorize these even more, okay? But the point is that sometimes it is possible to have this kind of calculations, and you see that this numerator turns out to be exactly the denominator. So it means that this fraction is actually indeed equal to 1. So that is also one way to do that. But I recommend you to solve the same problem using factorization. Yes, that is also possible. Okay. Okay, so let me give you another example. So number 10, I want to simplify this expression. A to power 8 plus 2a to power 4 x squared plus x to power 4, yes, multiplied by a to power 4 minus x to power 2 divided by a to power 2 plus x multiplied by a to power 6 minus a to 4x plus a squared x squared, and finally minus x cubed. Okay? We want to simplify this expression. So it means that, first of all, it is in factorized form. It's also in factorized form. This is a product. It's a product. But no factor is in common. Either it cannot be simplified, or I can factorize even more so that the common factors emerge. How should I do that? I don't think it's hard for you to see this. This is a quadratic rule. So let me just do it here for you. Do you see the pattern? Yes? This is a trinomial. 2 of them are complete squares, and the middle term is exactly the term that I need. If I take the square root of this, this is a4. The square root of this is x2. If I multiply them and multiply it 2, that's exactly the pattern. So then it means that I can simplify it and write a to the 4 plus x to the 2 to the 2. And then hopefully you can recognize this is a conjugate pattern. So let us not explain it, because this is very simple for you by now, hopefully. A squared minus x, and then I have a squared plus x. In the denominator, this is good, by the way. This will be cancelled finally. But here, is it possible to factorize this? The answer is yes. If I group them, okay, so here, for example, if I group these two together and these two together, okay, so let me do the factorization here for you. Between these two, I can factor a4 out. Then a2 minus x is left. And then here I can factor x squared out. And then a squared minus x is left. And that is a good way of grouping, yes, because now a common factor emerges, and I can pull a squared minus x out. So if I pull a squared minus x out, from this term, a to the 4 is left, and from that term, positive x squared is left. And you know that the sum of the completed squares are not factorizable in the realm of real numbers. We need complex numbers. So we keep it like that. And then you see that a squared plus x, and then this a squared plus x are actually simplified. Yes. And this a to the 4 plus x squared, one of them is simplified with one of them here because there are two factors. Yes. So let me just drop this 2 here. So then what is left for me is a to the 4 plus x squared and this one. A to the 4 plus x squared, one of them is left, and a squared minus x is here. And in the denominator, sorry, this one is also cancelled. Yeah, very good. So this one and that one are also cancelled. So I can take this away. And what is left in the denominator? Nothing. Nothing means when I have divided all of them equal to 1. So in principle, I need to write 1. And then we don't write 1 in the denominator. So that would be our final answer. Okay? So I will give you one more here, one more example, number 11. I want you to simplify this for me. So I have x to the 2 minus y to the 2, the whole expression to the 3, plus y squared minus z squared to the 3, and then I will have plus z squared minus x squared to the 3, divided by this expression, x minus y to the 3 plus y minus z to the 3 plus z minus x to the 3. Okay, so I want to simplify this rational expression. The numerator is a polynomial in 3 variables. The denominator is the same. My goal is to simplify this. Of course, it seems horrible if you doesn't remember what we talked about before. There was a very famous identity. Let me remind you just briefly. If we have something in the box, let me change the color. So if I have something in the box plus the circle, something triangle, if I have the sum of 3 expressions or anything, numbers, is equal to 0, then you remember, we know that the cube of the first one plus the cube of the second one plus the cube of the third one is equal to 3 times the first one times the second one times the third one. And this will apply both to the numerator and the denominator. Look, if I take this one in the numerator, let us take this one, the box. Let us take this one to be the circle. And let me take this one to be my triangle. Yes? If I add what is inside the box to the circle to the triangle, let us see what happens. This x squared, only look inside. X squared will be cancelled by this negative x squared there. Negative y squared will be cancelled by this y squared, and negative z squared will be cancelled by this negative z squared. And what I am interested in, I am interested in the sum of the cubes, and that's exactly the sum of the cubes. So it becomes 3 times the product of these expressions. So if you don't remember this, it would be very hard probably to simplify this expression. So okay. In the numerator, I can write 3 and the product, x squared minus y squared multiplied by y squared minus z squared multiplied by z squared minus x squared. And then the denominator exactly follows the same rule. But if I give the role of the box to this, if I give the role of the circle to this, and if I give the role of the triangle to this. Again, look, if I add the box, the circle, and the triangle, this x will cancel that x, this y will cancel this y, and this z will cancel that z. So it means that the sum of the box, circle, and triangle is 0, and I am interested in the sum of the cubes again. So this means that I can write the same thing. So it becomes 3 times x minus y, y minus z, and z minus x. So first of all, you can see that these trees can be cancelled because now this is written in a product form. And now, hopefully, you can immediately realize what's going on. Yes, each one of them is a conjugate pattern. And then we don't need this, so let me just remove it. And then this can be factorized using conjugate rule, x minus y, x plus y. This can be factorized as y minus z, y plus z. And this can also be factorized as z minus x, z plus x. And then this tree and that tree are gone. X minus y, y minus c, y minus c, z minus x, z minus x. And then what is left for me is just simply x plus y plus z, and z plus x. And 1 is left in the denominator, but we don't write this in the denominator. Okay? So this is simplifying, how to simplify these rational expressions. So the main thing that you'll learn is again factorization. So if your skills in factorization is good, then you don't have any problem to simplify these expressions. Yes. Okay, now we want to little by little learn about the operations between the rational expressions. So just normal operations. We want to learn how to multiply them, how to divide them, add them, and subtract them. I will teach you how to multiply and divide in this session, and then it would be the topic of another video when I want to talk about addition and subtraction, which is a little bit more subtle than multiplication and division in this case. Okay. Now the first operation between two rational expressions that I want to talk about is how to multiply rational expressions. But there is no new rule actually. If I have two fractions, a over b, and I want to multiply it by another fraction, c over d, you know the rule, yes? I need to multiply the numerator to the numerator and write it as the numerator of my new fraction. And I do the same thing for the denominators, yes? But of course, even though this is always correct, but it is better to simplify before going on, yes? So here I have a and b as one single fraction. This can be simplified on its own. This also can be simplified on its own. But look here, if you look ahead a little bit, if you multiply, then what happens? This b and d becomes the factors of the denominator of the result, yes? And then these two become the factor of the numerator. And then I told you that factors can be simplified. So if there is a factor in A that can be simplified with B or D, you can simplify it. And if there is a factor in C and a factor in B and D that can be simplified, you can simplify it. So if you look ahead of you, you don't need to multiply first and then simplify, which I really want you to avoid that, even though technically it is correct. I want to simplify before doing the multiplication and then do the multiplication. So it means that if possible, look and simplify these two in a vertical form. If possible, simplify these two. And of course, because A can be simplified with D as well at the end, so you can do it first. You can simplify A with D if possible. You can simplify B with C if possible. So you can simplify the product in a vertical manner between A and B, C and D, and you can also simplify in a crossway manner, yes? So, and I really want you to develop this habit in your brain when you're dealing with rational expression. Even though technically you can multiply and then simplify, it's much, much easier if you simplify first and then continue. Okay, so that is the point of this one, and that's exactly the same thing when you're dealing with rational expressions. The only difference is that if you have numbers, it is easy to do the simplification because you really don't need to factorize them. You are familiar with the numbers, but with rational expressions, we cannot do that. We usually have to factorize the polynomials so that the factors become clear, and then we can simplify it. Yes. So let me give you an example, and some examples actually. So example. So I would say simplify again here, but I mean here you need to multiply and simplify, of course. So number one, this is the first one, 3x over 4y multiplied by 8y squared divided by 9x. Okay? So here you see I have a rational expression, I have another rational expression, my goal is to multiply. What I do, I look vertically first here. Is there something that I can simplify in this fraction on its own? No. No factor in common. The answer for this one is again no. But then it doesn't mean that this is not possible to simplify that. You need to do the cross-manner simplification if possible. I have factor of 3 and x here. 9 is 2 factors of 3, 3 times 3, and 1 factor of x. So yes, I can simplify. I can simplify 3 by 3, it becomes 1. I can simplify this 9 by 3, it becomes 3. So the numerator of one of them with the denominator of the other one, and vice versa. So then x is also another factor, so I simplify this, and I also simplify that. But again, another simplification in this way. 8 to 4 can be simplified to 2 times, 4 to 1, 4 to 4, 1 time. And then y divided by y 1 time, y squared divided by 2, 1 y. 1 y is left. So if you look here, I have 1 over 1 left. Yes, 1 times 1 is 1. 1 times 1 is 1. Then I have this product. Then I have 2 times y left here. And 3 times 1 is 3. And after simplification is done, I start multiplication, which is trivial actually in this case. 1 times 2y is 2y, and 1 times 3 is 3. I'm not saying do all these steps, but you need to think in this way, but just write faster. Okay, let me go to the another example. Let us increase the level. I think this is not something hard for you. So let us deal with more interesting problems. X squared minus x divided by x plus 5 multiplied by x squared plus 5x plus 4 divided by x to the 4 minus x to the 2. Okay, I want to simplify this product. Okay, so I have two rational expressions multiplied together. I need to factorize every expression involved here. So this one is trivial. I pull x out, it becomes x minus 1. This denominator cannot be factorized anymore, so it is x plus 5 multiplied by, the numerator is a trinomial, but it's a very simple one. X squared, the coefficient is 1. So that's the common term identity, if you remember. So I put two x's here and there, and I ask two numbers whose sum is positive 5 and the product is positive 4. Super simple. 1 and 4. Yes? Plus 1 plus 4. And then here, x squared is in common, so I can factor it out. So if I factor it out, let me write it down here. If I factor x squared out, then x squared minus 1 is left. But x squared minus 1 actually reveals a conjugate pattern, so I can factorize it even more. So then it becomes x minus 1, x plus 1. Okay, now look here. Is there any vertical simplification possible here? No. The factors are x and x minus 1. The factor here is x plus 5, nothing in common. Can I simplify something vertically here? The answer is yes. So I simplify this vertically here. X plus 1 is one factor, x plus 1 is that factor. So when I divide, this was possible to simplify vertically. Nothing more. But now let us go to cross-manner simplification. X here is a factor. X squared is x times x. So this x here from the numerator of the first one, and with x squared here, the denominator of the second one, can be simplified. So then x squared is gone, only 1x is left. And the same story for here. And then this is 1 left. X minus 1 and this x minus 1 are gone. So 1 is left for this one and 1 is left for this one. And I don't think you really need to write the intermediate step again. So you can just do it in your head. 1 times 1 times 1 is 1. X plus 5 times x times 1 is x plus 5 times x. And I usually prefer to remove the pair of brackets, but this is not mandatory. So it becomes x squared plus 5x. Okay, so number 3. So I would write this for you. X squared minus 4 divided by x squared minus x minus 2 multiplied by x squared minus 3x minus 4 divided by x squared minus 2x minus 8. Actually, this is, I would consider this an exercise in factorization of polynomials of second degree, rather than consider this. But yeah, I told you that there is nothing new in this lesson. So if you have improved your skills in factorization, no problem. But of course, I will give you harder problems that you really need to think about. Okay, so if I want to simplify this, I need to factorize. I think everything is transparent. This is exactly the conjugate pattern. And I have 3 trinomial. So all of them have this identity. So I put something like this for that one. The same here. The same here. Okay. And then here. I ask myself, I need 2 numbers whose sum is -1 and the product is -2. It's simple, yes? It's minus 2 and +1. +1, -2. Make sure that we haven't made any mistake. If I multiply them, it becomes -2. If I add them, it becomes -1. Good. I need 2 numbers whose sum is -3 and the product is -4. So it's -4 and +1. Yes, am I right? If I multiply them, -4. If I add them, -3. And then I need 2 numbers whose sum is -2 and the product is -8. So this becomes -4, +2. Multiply them, -8, add them, -2. And then I need to simplify. Is it possible to simplify vertically here? The answer is yes. So I can simplify this x plus -2 with x minus 2. 1 is left here, 1 is left here. Why 1 is left? Let me emphasize again, because I'm dividing. Yes, I'm not saying, so I have seen these mistakes some students make. So when you divide, when I say nothing is left, usually this is a sloppy language, nothing means 0. But here is not 0. So you see, if I divide 2 numbers, a and a, nothing is left means 1. When I subtract 2 numbers, nothing left means 0. But in principle, that's a sloppy language. Is it possible to simplify something vertically here? The answer is yes. I divide by x minus 4, it's 1. I divide by x minus 4, it's 1. But now it's not finished yet. Don't be in a hurry. It might happen that I can simplify in cross-manner way, which I can in this case, yes. X plus 2 in the numerator of the first one, x plus 2, the denominator of the second one, can be simplified as well. So I will have 1 here and 1 there. And then, by the way, this one is also gone with that one. So 1 is left here, 1 is left here. So you see, all the way around, I am multiplying, dividing 1s together. So definitely the answer becomes 1. But look again, let me emphasize. Is it indeed exactly equal to 1? The answer is no. Because 1 is always 1. But this expression is not always equal to 1. It is equal to 1 if you choose that value for x such that these 2 denominators are not equal to 0. None of them. In that case, which is, of course, there are 2 numbers that this gives you 0. There are 2 numbers that this gives you 0 if you use, for example, ABC formula to find the roots. Yes? So 2 numbers here, 2 numbers there, and you see the numbers. The numbers are -1 and 2 here. The numbers are 4 and -2. Yes, so 4 numbers. Except for those 4 numbers, this expression is equal to 1. So there is an exception. Yes, be careful about the domain of validity if you're doing with fractions. And let me solve a little bit harder problem, and then we go to division, and this would be the end of the lesson today. Okay, so number 4, let me write this here for you. So number 4 is x to the 3 plus y to the 3 divided by x to the 4 minus y to the 4 multiplied by x to the 2y plus y to the 3, x to the 4 plus x to the 2, y to the 2 plus y to the 4, multiplied by x to the 2 plus xy plus y to the 2, and then divided by x plus y. Yes? We want to simplify this. So here, be careful, first of all, you factorize everything, and you can also simplify vertically, but because I am multiplying 3 fractions, in the cross-manner way, I can simplify, if possible, something from here and something from there or there. Yes, these are 2 in the denominators. So I would say that you can simplify anything in the numerator by anything in the denominator, okay? It doesn't matter, is it the denominator of the same expression or the denominator of the other expression, okay? So that's the general rule. But because here we are, some of them need some calculation, so if you don't mind, let me do them one by one, yes? Hopefully, so not to risk about being outside the frame because I'm just taking the videos myself. So let me write this here, and then we can teach the other one, division, on the blackboard, so that we don't need to waste time for cleaning. Okay, so so I would say that let me give numbers here. These are completely subjective. So if you don't mind, let me call this one number 1, this one number 2, this one number 3, 4, 5, and 6. Yes? And let us see what we can do. For example, number 1, so x to the 3 plus y to the 3 can be factorized. If you remember the correct identity, of course. Yes, do you remember using identities to factorize polynomials? This is a very famous one. So it is x plus y, x squared minus xy plus y squared. This is the factorization of number 1. Factorization of number 2 is also simple. It's the conjugate rule 2 times, if you remember. This becomes x squared minus y squared multiplied by x squared plus y squared. I mean, if your knowledge about factorization is a little bit shaky, you need to go back and watch the previous videos. This is why I'm going faster here, because I'm assuming that you have already listened and watched those videos, so your skill about factorization is completely acceptable at this level. And then again, this emerges. This is a conjugate pattern on its own again, so it becomes x minus y, x plus y, and then you know that the sum of these squares cannot be factorized in the set of rational numbers, in the set of real numbers. This is number 2. Number 3 is very clear. So number 3, so I have x to the 2, y, plus y to the 3. So it is clear that I can pull out y. It becomes x squared plus y squared. And then I go to number 4. The number 4 is the most tricky one. So I don't know how much do you remember about factorization of polynomials. Sometimes adding and subtracting the same term will work. Yes? So here, the trick is to write x4 instead of x squared plus y squared. I write 2x squared y squared with the intention to make a quadratic pattern emerges. This is a quadratic pattern now. And then I have to compensate because I have only one x squared y squared. I have written 2 times, so I need to subtract x squared y squared at the end. Yes, but what is the benefit of doing that? It becomes clear shortly. So here I have the quadratic rule, then it becomes x to the 2 plus y to the 2 and then to the 2. And then I have minus, instead of x squared y squared, I can simply write x squared as a whole to the 2. And then the reason becomes now clear that this is nothing except a conjugate pattern. So what can I do now? I can take the square of the first one, x squared plus y squared minus the square of the second one. The same thing is square root of the first one plus the square root of the second one, to write them in an organized way, in accordance and coherent with the other things. So let me write minus xy in the middle, x squared minus xy plus y squared, and the same thing here. So it becomes x squared plus xy plus y squared. Yes. And then you see that number 5, we don't need to do anything, because this number is one of this expression is exactly one of these factors which appears in the denominator of the first one. So when I am simplifying in the cross manner way, this will be gone. And by the way, this cannot be factorized anymore in the set of real numbers. And x plus y, we don't need to do anything. This is already in factorized form. So if you don't mind, let me clean 5 and 6. We don't need to do anything with them. And then finally, I write my question mark. So the question mark becomes equal to. So instead of number 1, I replace this expression, x plus y times x squared minus xy plus y squared, divided by, instead of the denominator, which is number 2, I put this expression in. So it becomes x minus y, x plus y, and then I will have x squared plus y squared multiplied by. Let us go to the next expression. Number 3, I have already done that here, so it is just y, x squared plus y squared. Number 4, I did it here, so it is x squared, you see it's here, x squared minus xy plus y squared multiplied by x squared plus xy plus y squared. Yes. And then finally, I go to the next one, which I didn't do anything with it, so I just copy and paste the last expression. It was not possible to factorize it more. Now, again, anything that you see, any factor that appears in the numerator can be simplified by any factor that that appear in the denominator, vertically or in crossway manner. So here, for example, this one and that one are gone. Nothing more vertically here, nothing vertically here, nothing vertically here. But x squared minus xy plus y squared from this fraction can be simplified with this one from the denominator of that. By the way, if you like, you could simplify x plus y from here with x plus y from there. It doesn't matter. Okay, and then you see x squared plus y squared in the denominator of this one can be simplified with that one. So let us ignore just 1, 1. Everything remains 1, yes? And then what's happening? Yes, I have this one simplified with that one. So all of these are left with 1. So let me write them, okay, to make sure no confusion arises here. So it's 1. Yes, and then look, let us not confuse ourselves. So 1, 1, 1, yeah, 1y here. So this is 1y left and nothing here. So the answer would be y in the numerator. And let us go to the denominator. X minus y is left, and then x plus y is left. So it becomes x minus y times x plus y. Yes, as I told you, I usually prefer to remove the pair of brackets. Yes, so I would write y divided by, this is the conjugate pattern, x squared minus y squared. Okay, so you see, I will consider this as a practice in the factorization more. Okay, the last part of the lesson today would be division of rational expressions. So let me write the title. Okay. So the rule of the division is exactly the same as the rule of fractions, division of fractions. So if I have A over B divided by C over D, what can I do? If I want to divide this, I would write A over B. I will change this division to multiplication, and then I swap, interchange the numerator and the denominator of the second one. So in principle, I really don't need to teach anything at all, because by this rule, I change the division to multiplication, and we just practice how to multiply. So the same rule applies. Okay? So it means that if you want to simplify, so you can don't look here. If I ask you to simplify, you can simplify A with B. You can simplify C with D. You can simplify in cross manner A with C, and you can simplify B with D. If you look back here, A and B can be simplified, okay. C and D can be simplified, okay. A with C can be simplified. So at this stage, if you want to simplify, which I don't recommend, you should simplify the numerators together in a horizontal way, and then B with D, okay? But I prefer to write this in the form of a product and then simplify as before, okay? And usually this symbol is not that used. I prefer myself to write A over B divided by C over D, okay? Something like that. This is also good to know. First of all, how can I simplify? Again, you can simplify A with B because that's the same story. I can simplify A with B. I can simplify C with D. I can also simplify A with C. So you see A with C, and I can also simplify B with D. But how should I answer this? The answer is this. If you want to write the answer, you need to multiply A with D, yes? So it means that you need to multiply these numbers that are far away from each other and put them in the numerator. And then B is supposed to be multiplied by C. It means that the numbers that are close together should also be multiplied, and I put them in the denominator. So I would prefer to write this usually. Okay, but that is just a matter of notation and symbols. One thing that I want you to know is that if I have 1 over A over B, you don't need to waste the time. In principle, you need to write 1 over 1 instead of 1 and write A over B, and then multiply these two numbers which are far away from each other, so it becomes B, and multiply these two numbers which are close together and put them in the denominator. So I really want you to know this by heart quickly. So if I have 1 over a fraction, the fraction becomes B over A. And of course, I don't know, if I have A divided by B over C, for example, this can be immediately written as AC over B. Yes, because A is A over 1, and then again I use the same rule. Or if I have A over B divided by C, then I can give a 1 to here. 1 times A is A, B times C is BC. So these are the things that usually happen in exercises. I want you to understand that, but all the time you really don't need to do everything from scratch. It's better to speed up. Okay, so you see that there is nothing new. So I could say that, okay, division is turned to multiplication and then the previous list, for short, yes? But let us do some exercises together and then we are done. So let me write an example here. So again, we want to simplify these expressions. So 3 Number 1, 3a squared plus 12 divided by 3a squared minus 15a, and then divided by a to the 4 minus 16 divided by a squared minus 3a minus 10. This we are supposed to do. A rational expression divided by another rational expression. Okay, so I need to use this rule. What should I do? I need to write the first fraction. And you know that. You can look ahead. At the end, I am supposed to factorize. So we can factorize. Let me do the first example like this. So I will write 3a squared plus 12 divided by 3a squared minus 15a. I change this to a multiplication, and then I swap these two. So it becomes a squared minus 3a goes up, a squared minus 3a minus 10 goes up, and a to the 4 minus 16 goes down. And then, because now I want to multiply, I will follow the rules for multiplication, so I have to simplify, to factorize these polynomials as much as possible. So here, for example, I can factor a 3 out, then a squared plus 4 is left from here. Here I can factor 3a out, and then from here a is left, from here minus 5 is left. Multiplied by, again, this is a very simple one, a common term identity. So I put a here and there, and I ask myself, I need two numbers whose sum is -3, and the product is -10. So that is -5 and +10. +2. And then this one is two quadratic patterns, yes? Let me just write it here below. This can be factorized to a squared minus 4 using the conjugate pattern. But this one, a squared minus 4, can be simplified, can be factorized more. So then it becomes a minus 2, a plus 2, and a to the 2 plus 4. And now, can I simplify something vertically here? The answer is yes. 3 is gone. Nothing vertically anymore. Here, I can simplify these two vertically. And I can simplify this with that, the cross-manner way, and this one with that one, also in cross-manner way. And then 1, 1, 1, 1, if I multiply them, so let me write the answer here to save the space. So 1 times 1 times 1 times 1 is 1. And then 1 times a plus a minus 2. So it's a times a minus 2. And as I told you, I prefer at the end that I am not hopeful, I don't have any hope to simplify anymore. I write it back in the form without brackets. So that is the division. Okay, so let me give you 3 more examples. So number 4, let me write it in this form. X squared minus x minus 2 divided by a squared minus b squared divided by x minus 2 divided by a squared plus ab. Okay, so that is this way of writing. A fraction in the numerator, another fraction in the denominator. But the idea is the same. So here I would factorize this using this trick. I need two numbers whose sum is -1, the product is -2, so those numbers are -2 and +1. This one is a very simple thing, a minus b, a plus b, conjugate rule, x minus 2 is just x minus 2, and here I can factor a out, then a plus b is left. Okay, and then look here, these blue lines show how I can simplify. The numerator of each one of them can be simplified together. The denominator is the same. So you see here, x minus 2 is in the numerator, and x minus 2 is again in the numerator. So this can be cancelled. 1 is left from here and there. And nothing is in the numerator anymore. But in the denominator, this one can be simplified with that one. So then what is left? X plus 1 is left from there. A minus B is left here. And then 1 is left here. A is left there. Now I want to if I want to do the operation, the division operation, I need to multiply these numbers which are far away from each other and put in the result in the numerator, and then multiply these two close together and put them in the denominator. So this means that I need to multiply these two and these two. So if I multiply A with that, it becomes A times x plus 1. And if I multiply 1 with that, it becomes A minus 1. And hopefully by this stage, you know that you are not allowed to simplify this A with that A, because A in this is a factor, but not here. It's a summand. So then I prefer to multiply everything back to write it, even though it is not mandatory. Okay. So let me give you another example here, number 5. So 28 x to the 3 minus 51 x squared minus 27x divided by 49x squared plus 42x plus 9. I want to divide it by 4x minus 9. Okay, so here, if I want to do this division, I need to use the same rule. I write the first expression, so let me write it for you. And of course, I am looking ahead, so I know that I am supposed to factorize everything. At least at this step, I can factor x out. Then I will have 28x to the 2 minus 51x minus 27. And then you see here, this is, even though it's a trinomial, but this is a complete square. So it might be the case, because I have two complete squares, so it might be the case that this is a quadratic rule. So you go to scratch paper, take the square root of this is 7x, take the square root of this is 3, and you yourself multiply it by an extra 2. And then you see that this becomes exactly 2 times 3 times 7 is 42x. So that is indeed a quadratic pattern. So then it becomes 7x plus 3 to the power of 2. The first one to the 2, 2 times the first one times the second one to the 2. But the important point is that what happens here? Here, when I don't have any fraction, it means that the denominator is 1. So I will change this to a product. Then I will interchange these two. So 1 goes up, and then 4x minus 9 goes down. Okay? In this form, it is not possible to simplify anything. I don't see any factor in common. So the problem is probably here. Either it cannot be simplified at all, or the point is here. We need to factorize this. Okay. But this is of big numbers, so I just wanted to remind you about what we talked about. So if the numbers are big that we cannot guess, you know how to do that using the ABC formula, okay? So let me do it. I'm just trying to remind you of different types of tricks and techniques that you learned before, so that you don't forget. So I don't know, if you are clever, might be you should be able to guess this one. I'm not saying that this is hard. It is not that hard. For example, here I have 4x and 7x multiplied to this. This is one of the possibilities. If you can do some guesswork, of course it is easier. But if you cannot guess, I want you to know what we need to do. Do you remember? First, so my point, I want to factorize this. So I'm focusing on factorizing this for the time being. So 28x squared, I put this equal to 0 myself to find the roots. And I have already, I think, did the calculation, so I remember the numbers actually, so I don't spend so much time. So ABC formula, yes. So I need to calculate delta. So let me write the formula for you. It's minus b plus or minus square root of b squared minus 4ac divided by 2a, where a is 28, b is negative 51, and c is minus 27. So if you put these numbers, it becomes 51 plus or minus square root of minus 51 to power 2, and then minus 4 times this times that. But there's a negative sign here, so let me write minus 4 times 28 times minus 27, and then divided by 2 times a, which is 2 times 28. Yeah, I did this calculation before I start the video. This square root of this number becomes 75. So this becomes 51 plus or minus 75 divided by 2 times 28 is 56. And then I have two numbers. 51 plus 75, it is 126 divided by 56. I can simplify this, for example, by 2, 63, 28. I can simplify by 7, becomes 9, 4. So 9 over 4 is 1 root. And the other one is 51 minus 75. So it's minus 24 divided by 56. So I simplify by 8. It becomes minus 3 divided by 7. So these are the roots. And then do you remember, I had this formula before. We talked about this before. So this becomes a times x minus the first root, x minus the second root. This is the factorization of this quadratic polynomial, and it doesn't matter at all which one you call x1, which one you call. Let me call this one x1, and let me call this one x2. So then it means that 28x squared minus 51x plus 20 minus 27 is equal to a, which is 28. No, not 0, sorry. Is equal to, instead of a, I put 28, x minus x1, which becomes 9 over 4, and x minus x2, but x2 has a minus sign, so it becomes negative, negative, it becomes positive 3 over 7. And then because we are supposed to usually factorize by default on the set of real integers, these are not acceptable, but that is easy. You can just immediately see that 28 is 7 times 4. So I multiply 4 inside the first bracket and multiply 7 inside the second bracket. So this, it becomes 4x. When I multiply 4 here, 4 cancels, so it is 9 minus 9. And then the same here, 7x plus 3. Okay? So now you know the factorization of this expression, and now you see that there are some factors in common emerging. Yes? So if you don't mind, let me write the rest of it here. So here, after I did that, I will come back here and simplify. So x, instead of this expression, I just write this one. 4x minus 9, 7x plus 3. And then I have 7x plus 3 to the power of 2 multiplied by 1 over 4x minus 9. Yes, and then you see that this one, and this one, one of them. There are two factors. So one of them is gone, 7x plus 3 is left. Here I have two factors of this, but one of them is gone, one of them is left, and this one is gone with this one. So x times 1 times 1 times 1 is x. And then 7x plus 3 is left times 1 is 7x plus 3. And I'm not allowed to simplify these x's because x in the denominator is not a factor. Okay. And then it might happen that we have a combination of a product and a division in one problem. So let me give you an example of that type, which would be our last example. Okay, so this is the example that I have chosen for you. So I have x squared plus 5x divided by 3x squared minus 4x minus 20 multiplied by x squared y plus y divided by 2x squared plus 11x plus 5 divided by xy squared and then 6x squared minus 17x minus 10. Yes? Okay, first of all, I don't think there is a confusion here. So, for example, if I have A times B divided by C, you can interpret it in two ways, but both of them are equivalent. You can think that, okay, should I first multiply and then divide? So this means that you write AB and then divide by C. But you might think that should I divide first and then multiply? Of course, this is no difference because A times, instead of B divided by C, let me use this symbol. And when I multiply that, you will see that the answer is the same. Okay? So there is no difference. So that's, you know, of course, before, there is no priority with multiplication and division. So the important thing here is we need to, there are some examples here, we need to simplify those. Okay, so let us do these things first. We need to factorize them first. But that is not a big deal. So I will write it and I will change this to the product and then I will interchange these two. Okay, the main problem is that, let me see if I have written correctly. Yes, so I want to factorize this. So let us do this one by one. I think these numbers are not that big. We can actually somehow find the numbers. Yes, so you see there is a 3 here. You know the trick. I ask myself that I need two numbers whose sum is the product of these two. Yes, which is minus 60. So product is minus 60. The sum is supposed to be minus 4. Yes, so I think it's not that easy to hard to guess. Yes, the product is supposed to be minus 60. The sum is supposed to be minus 4. So the answers are minus 10 and positive 6. Yes, yes. So it means that I break the middle term. Instead of minus 4x, I write minus 10x plus 6x minus 20. Yes, then I will take these two together and these two together. Yes, so then becomes I factor 3x out between these two. So x is left from here, 2 is left from here. Between these two, I factor a negative 10 out. So then it becomes x plus 2. And then you see that x plus 2 emerges, so I can pull it out. Then I will have 3x minus 10. Of course, at this stage, if you can do some guesswork and you can just immediately come to this, you say 3x squared is a multiplication of x and 3x. And if you can fine-tune these numbers, you really don't need to go through this process. But what I'm saying is that, okay, instead of this expression here, I can write that. Let me jump to the next one. Let me draw a line here. So 2x squared plus 11x plus 5. Again, the same story. I ask myself, the product is 10. The sum is going to be 11. What are those numbers? 10 and 1. As simple as that. So it means that I break the middle one into x and 10x. And then, of course, I have a 5. Then I take these two together and these two together. The reason I am doing it fast, because if you don't understand, please go watch the videos about factorization. So here I take x out, it becomes 2x plus 1. And here I take 5 out, it becomes 2x plus 1. Then I factor 2x plus 1 out. Then I will have x plus 5. And then I go to the last one here. So 6x squared. So what is the product? The product is supposed to be, so let me write it with a different color. So the product is supposed to be minus 60. Yes, so the product is supposed to be minus 60, and the sum is supposed to be minus 17. Can you guess? The numbers are not that hard, so the numbers are minus 20 and positive 3. Yes, if I multiply them, it becomes that. If I add them, it becomes this. So if I want to factorize 6x squared minus 17x minus 10, I need to divide this into two pieces. One piece is positive 3x. The other piece should be minus 20x, and then I will have a minus 10 at the end. And then, of course, as before, I take these two and I will take these two. Between these two, I can factor 3x out. So then it becomes 2x plus 1. And then I will take minus 10 out. It becomes 2x plus 1. And then I take 2x plus 1 out. And then I will have 3x minus 10 left. So that is a very good refresh of your memory about how to factorize these trinomials. And then the question mark that I want is equal to. The factorization of this is very simple. I just take x out. So it becomes x plus 5. The denominator of the first one is here, x plus 2, 3x minus 10. X plus 2, 3x minus 10. Multiplied by, this one is very simple. I can just factor x out, y out. X squared plus 1 is left. This one, I have done it here. So the answer is 2x plus 1 times x plus 5. And then I need to change this to product, but I need to remember to swap these two. Xy squared is already in factorized form. It goes to the denominator. Yes. And then this one is this expression. So 2x plus 1 and 3x minus 10. Okay. Vertically, simplification is probably not possible, yes, but cross-manner way, this x, for example, with that x are gone, so one here, one there. This y here and this y here is gone. One y is left. Here is 1. And then what is left more? So this x plus 5 is 1. This x plus 5 is 1. And this 2x plus 1 is gone. This 2x plus 1 is also gone. And then this 3x minus 10 with that 3x minus 10. Okay, so what is left in the numerator? 1 times 1 times 1. This one is x squared plus 1. And in the denominator, 1y is left here, and x plus 2 is left here. And I told you that I usually prefer to write this as x squared plus 1 divided by a multiply xy plus 2y. Okay. I hope that this video was somehow useful for you. Below the video, I will put a link to the PDF file for the exercises related to what I covered in this session. And as usual, I will solve them in a separate video and upload them later. But now I want to change a little bit about this because the diversity of the problems becomes more and more when we are going further and further. So might be I will have one session of lesson and more sessions of practice. Okay, so below this video, you will find the first part of the exercises. I want to have 2 exercises sessions for the material that I covered here. So below this video, you will find the first set of exercises. I really recommend you to start working on them if you want to improve your skills and understanding about the subject. Okay, so the next video would be the solutions of the problems that you can find right now below the video. And when I am solving that problems in the next video, I will upload another set of problems for the same material that I covered today. Okay, so we will have 2 exercises session for this session. Okay, if you have enjoyed the video and you really think that somehow it was useful for you, I would be very happy if you can give me a thumb up, and I would really appreciate if you can subscribe to my channel. So then it would be very good for me that if I can see, because I doing this totally for free, and it would be really encouraging if I think and if I see that this is going to be useful so for some people. Okay, until the next video, goodbye. Thank you.